All right, boys and girls, welcome back. We'll see how much we can do today. I'm not going to promise that we get through all of it. We might need one more video, but please work along on this at your own rate. Make sure that you understand piece by piece by piece. Okay? At this point, you should understand the alkanes, single hydrocarbons with single bonds, the alkenes, hydrocarbons with double bonds, and the alkynes, the hydrocarbons with triple bonds. Okay? We are going to quickly look at some aromatic compounds, and then we're going to look at some functional groups today. So it says here, until now, you have worked on aliphatic hydrocarbons. So those are your alkanes, alkenes, alkynes, which are your line structures, chain structures, and the cyclo ones as well. The next group we will look at are the aromatic hydrocarbons. And again, here is your chart, your family tree. Again, this looks like it would be a wonderful kind of exam question or test question. You already should know how to do the classification of matter. We've gone over many times the classification of organic molecules. Might be a good thing to know too. So it says aromatic hydrocarbons are unsaturated hydrocarbons. Remember what that word unsaturated means, meaning that not every bond is connected with a hydrogen, with stable ring structures. Okay. The simplest aromatic compound, benzene, can be represented in the following ways. So we see here we've got this, it's a ring, like the aromatic ones, but it's got some double bonds in it, and it's got 3 double bonds in it. Now, with those 3 double bonds, they could move to different spaces in there as well. Okay, so they could be in different spots of the ring as well. And actually, that's what happens. So if you were to actually look at the molecule at a very close level, you would see that these bonds are changing location all the time. So you can show it like this, or most of the time, this is the easiest way to show the benzene ring. Okay, so just so we know, how many carbons does it have? It has 1, 2, 3, 4, 5, 6 carbons. Okay, its root name is benzene. Okay, when naming the carbon ring is generally considered to be the parent chain, the names of the substituent groups precede benzene, the name. So here we have the ring. The ring is called benzene, and then we have an attached methyl group. So this becomes methylbenzene. And since we have one attached methyl group, we don't need to specify the location on the chain. Okay? It just becomes one methylbenzene. Okay? And it says, when 2 or more substituents are attached to the benzene ring, number the carbons in the ring to give the substituents the lowest numbers possible. Name the following compounds. Okay? So, and then if the numbering is possible on either way, then you want to give put them in alphabetical order so that the one that comes first in the alphabet has the lowest possible number. Okay? So this is a good example of this one right here, our first one. So the parent name is going to be, if I can move this a bit, hopefully it stays and doesn't fall, it's easier to write. The parent name is going to be benzene, B-E-N, benzene. Ene, right, for the double bonds. Okay? Because we can't see it, but there are double bonds in there. Remember what this picture means. Okay, so what do we see? I see an attached methyl group, and I see an attached ethyl group. Okay? So the question is, on this ring, are we going to start numbering it from the methyl? So this is 1, 2, 3. Or are we going to start numbering from the ethyl? 1, 2, 3. Since E comes before M on the benzene in alphabetical order, we're going to give the ethyl group priority and give it number 1 carbon. So this is number 1, this is number 2, this is number 3. Okay. So then this becomes 1 ethyl, 3 methyl benzene. Okay? All right. So let's look at this one. So again, we've got this ring structure. The parent name is going to be benzene. Okay, and what do we have? We've got, here's our friend methyl at the top. That's an attached methyl group. And then we've got 1, 2, 3, 4 carbons. That makes a butyl group, right? So the question again becomes, who gets number 1? Does the methyl group get number 1? This becomes 1, 2, 3. Or does the butyl group get number 1? This becomes 1, 2, 3. Well, when there's a confusion over which one should get 1, 2, or 3, then alphabetical order takes precedence. B comes before M in the alphabet, so this becomes 1 butyl, 3 methyl benzene. Okay? This one is a little bit more straightforward. We've got 2 attached methyl groups to the benzene ring, and so it doesn't really matter which one gets 1 or 3, because this could be 1, 2, 3, this could be 1, 2, 3. It's going to be the same either way, it doesn't matter. So this becomes 1, 3, and then there are 2 of them, so we have to use the prefix di, methyl, benzene. 1,3-dimethylbenzene. Okay. This one has 3 methyl groups on it, so we're going to use tri for 3. So we know it's going to be, this one is going to be a trimethylbenzene. Okay, so again, probably our ordering doesn't matter. So this is 1, 2, 3, 4, 5. So it's going to be 1, 3, 5, trimethylbenzene. Okay, so this one here, we've got a methyl group and we've got an ethyl group. So this one, because I know some of you are going to ask, how is this different than number from A? Well, it's not different from A at all, okay? So 2 carbons there, it's going to be considered number 1. It's going to be considered carbon number 3. So this then becomes the same as before. This becomes 1 ethyl, 3 methyl benzene. Okay? All right, we've got a quick review at the bottom here. So what's the first thing you need to recognize? So when we look at something like this, the first thing we should see is that we've got all single bonds. So this is an alkane. Right? So all single bonds, it's an alkane, and it's forming some sort of line structure. So first thing we need to do is find the longest chain. So 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. However you cut it, it's going to be 7. So the parent name for 7 carbons is hept, and it's an alkane, so it's heptane. Okay. Now I need to give my substituent groups the lowest possible number. So 1, 2, 3, 4, 5. Or 3, 4, 5. 3, 4, 5. So this one, we could label it like this, or we could label it this way. So what's going to take order? Should the methyl group get order, or should the ethyl group get priority? E comes before M in the alphabet, so the ethyl group should get the lowest possible number. So this needs to be labeled 1, 2, 3, 4, 5, 6, 7. So this becomes 3 ethyl, 3 3-ethyl 4,4,5 dimethyl. It's always hard to fit it in. Dimethylheptane. Okay. This one, we've got a ring, so our root name is going to be cyclo for it. We've got 1, 2, 3, 4 carbons in the ring, so it's going to be a cyclobutane. And then we've got 2 attached methyl groups. So it doesn't matter, this can be 1, 2, 3, this can be 1, 2, 3. So it's going to be 1, 3 dimethyl cyclobutane. Okay, C. The first thing you should notice about C when you're looking at it is that we've got a double bond. So this is an alkene, not an alkane. So that's going to really change. So our thing is we need to have, oh, and they've been kind, they've numbered it for us. So our double bond needs, your longest chain needs to include the double bond, and the double bond gets priority with numbering, and it needs to have the lowest possible number. So 1, 2, 3, 4, and then you go 5, or 1, 2, 3, 4, 5. I think I'm just going to go across like this. So this is, with 5, this becomes pent 2, which indicates where the bond is. It's on the second carbon. Ene, pentene. And then on carbon number 4, I've got 4, 4, there's 1, there's 2, 4, 4 dimethyl pent-2ene is the name of that one. Okay? Okay, looking at D, what's the first thing you should notice about D? D has a triple bond, so it's going to be a lot. So this is an alkyne, right? This is your classic alkane. This is a cycloalkane. This is an alkene. This becomes an alkyne with the triple bond. So your triple bond gets priority with the numbering, and they've been kind. So the longest chain is going to be 1, 2, 3, 4, 5, 6. It should be 1, 2, 3, 4, 5, 6. So this is hexine. This is hex 2-ine. And then on carbon number 4, we have 4-methyl hex 2-ine. That's what it is. And on my practice copy, I made a mistake. I just considered it to be an ethyl pentyne, but it should be an ethyne. Okay? All right. So, functional groups. This is when chemistry starts to become biology. And we start needing to deal with organic molecules that are living molecules and impact living systems. So, different things. So, number 1, the first thing we're going to look at is an alcohol. So another group of organic compounds are the alcohols. Alcohols contain what's called a hydroxyl group. Hydroxyl group is represented by OH, a hydroxyl group. And these other attached groups, we're going to go through a lot of them. There are oxygens that are attached, there are oxygen hydrogens, there are double bonded oxygens, there are nitrogens, there are even sulfurs that can be attached to. And these are all different functional groups that are put onto the main carbon chain. These functional groups that we attach now get priority with naming. Okay? So this one, alcohols contain the hydroxyl group, functional group, and are arranged in the following way. It's considered R, where R is a chain or a single carbon. R represents a carbon or a chain of carbons, OH, where R represents an unspecified alkyl group. Okay, so it could be, so it says e.g., for example, this methyl group. But it could be an ethyl group, a butyl group, a propyl group. It's just any kind of chain of carbons beyond the alcohol group. So, to name alcohols, identify the parent chain, again, which is the longest continuous chain of carbon atoms containing the hydroxyl functional group. Remove the E at the end of the name and add OL, which signifies an alcohol. Alcohol has OL on the end, so we're going to name these with an OL on the end to say that they're an alcohol. So the longest chain of carbons here is one carbon. So one carbon we know is meth, and this methane, and then we put OL on the end for an alcohol. So this becomes methanol. Methanol is what this is called. Okay, likewise we've got two carbons. We know that the root name is eth for that, ethane. And then we put OL on the end to indicate that it's an alcohol. So this becomes ethanol. Ethanol. We have these in our lab that we use. Okay? This one, 3 carbons. Okay? 3, propanol. Propanol. Okay? This one, we've got a carbon there, and we got a carbon there. Oh, there's 2 carbons. But wait, you say, I see a subscript. The subscript says 7. So that means that there are 7 carbons in there. 7 plus 1 is 8. So really this is an 8 carbon chain that's attached to the alcohol. So it becomes octanol. It's kind of probably what octopuses like to drink on a Friday night is some octanol. Okay? That's the basic naming rules, okay? Of course, it becomes a little bit harder. And it says the hydroxyl group may not always be at the end of the carbon chain, right? It could be in the middle of the carbon chain. To communicate its location, number the carbon atoms to give the OH groups the lowest possible numbers. Okay, so the longest chain here is 1, 2, 3, 4, 5. Right, so 5 is pent. Okay, it's an alcohol, so it needs OL on it. The alcohol is attached to the lowest possible carbon, so that would be carbon, so it could be 1, 2, 3, 4, or carbon 2, so it's attached to 2, so pentan 2-ol. And then on the third carbon, you see there's an attached methyl group, so it's 3-methyl pentan 2-ol. Okay? All right, this one's been kind and it's labeled our number of our carbons. So we've got, what's that, 6? So that's hexane. And then the alcohol group is on the third carbon, so that's 3-ol. Or you could write it, this one could be written as 3-hexane-ol. Would be okay as well. Okay, both naming conventions are fine. Okay, if there's no other attached groups to it, this one is fine, because then we know that the 3 is indicating where the alcohol group is attached to the parent chain. Okie dokie. All right, let's look at this one. So this one, we got 1, 2, 3, 4. So we have 4 carbons. So that's butane. And the alcohol group is attached to the second carbon, so butane 2-ol, ol for alcohol. Okay, and then on carbons number 2 and 3, we also see we have an attached methyl group. So this becomes 2,3-dimethyl butane 2-ol. Okay. This one, we've got a ring. So same naming function. So this becomes cyclo to indicate that it's a ring. How many carbons? 1, 2, 3, 4, 5, 6. 6 carbons for hex. Now, when it's on a ring like this and there's only a carbon, just one kind of functional group, there aren't any alkyl groups attached, there aren't any other functional groups attached. Do I need to say that it's on carbon number 1? No, we don't. It could be anywhere and it doesn't matter. So it's just hexanol. So this one's just cyclohexanol. Okay. These are the basic naming rules for alcohols. Now, this becomes important for later when we start talking about reactions with organic chemistry. Alcohols can be classified as either primary alcohols. Right? The word primary, prime means one. Like a prime minister is the first minister. A prime number are the ones that are kind of divisible by one or itself. Comes from the premier, means first or best. Okay, all of these things relate to the number one. So primary alcohol, think number one. Secondary, you are in secondary school, which is kind of high school, second. Or tertiary. Tertiary education is considered university education, college education. That refers to like third. Okay, so primary, secondary, tertiary. So we can have a primary alcohol, a secondary alcohol, or a tertiary alcohol. And this, how do we know? Because it's based on the number of carbons attached to the carbon atom binding the OH group. Okay, so here's your alcohol group, and here's the carbon. The alcohol group is attached to only one other carbon. Okay. This one, so it's primary. There's only one other attached carbon group onto the carbon that's attached to the alcohol. Okay. Okay. Remember what R means. R is some unspecified length of carbon atoms. It could be one carbon atom, it could be two, it could be many. But they just refer to that as R instead of writing out all of them. Okay, so look at this one. So here we have an alcohol group, and it's attached to a carbon, and this one at least is one carbon, and this one is at least another carbon too. So it's at least, this carbon is attached to two other carbons. So it's considered to be a secondary alcohol. Okay, and then if we look at this one here at the end, this alcohol is attached to a carbon that's attached to at least to three other carbons. That's what that means. So that's a tertiary carbon. Okay? So this one, it says, in the following example, the OH group is attached to a carbon atom which is attached to how many other carbons? So here's our alcohol group, and it's attached to this carbon. This carbon is attached to this one, and is attached to this one. So it's attached to at least two other carbon atoms. Therefore, since it's attached to two other carbon atoms, it's considered to be a secondary alcohol. Okay? All right, so 40 says classify and name the following alcohols. So classify here means, is it a primary, a secondary, or a tertiary alcohol? Okay? So the first thing we can do is, what is it? So let's classify. Is it primary, secondary, tertiary? So this alcohol group is attached to this carbon here. This carbon is attached to 1, 2, 3 other carbons. So this is a tertiary alcohol. Okay. Now what's the name of this thing? So the longest chain. 1, 2, 3, 4, 5. So it's pentan. And then the alcohol needs the lowest possible group. So it's going to be on the third carbon, pentan 3-ol. And then we see we've got one methyl that's on the third carbon too. So it's 3-methyl pentan 3-ol is the name of that one. Okay. So this one, is it a primary, secondary, or tertiary alcohol? So here's our alcohol group, and it's attached to this carbon. This carbon is only attached to one other carbon. That means that this is a primary alcohol. Okay, now what's the name of this one? So 1, 2, 3. 3 is propan. Now it's attached to the first carbon, so I really don't need to indicate that. So I can just say propanol, like that. I don't need to indicate it. But on carbon number 2, I've got 2 methyl groups that are attached. So this becomes 2,2-dimethyl propanol. Okie dokie. All right. The last one. Is this a primary, secondary, or tertiary alcohol? Okay, here's our alcohol group, the hydroxyl. It's attached to this carbon. This carbon is attached to 2 other carbons. So this becomes, it's a secondary alcohol. All right, so what's the name of this one? 1, 2, 3, 4. So it's going to have a parent name of butane, and our alcohol needs the lowest possible number. So start numbering from this side. So 2 all, and that's it. Actually, that's it. That one, butane 2 all. Okay, those are that's your alcohol functional group. Okay. The next group that we're going to look at are your organic acids. Okay. We don't really need to know what the definition of an acid is for this course, but an acid is basically, it's something that can donate kind of a hydrogen, a proton to something. It gives up or donates a proton to something. Something that accepts a proton is considered to be a base. Okay, so let's look at the structure. So the next group of organic compounds are the organic acids. They contain a carboxyl functional group, okay, which is this carboxyl group is considered COOH and has the following formula. So you notice that a carboxyl group has a hydroxyl with it. It's like an alcohol, but then it also has this double bonded oxygen. Remember that oxygen has 8 electrons in total, right? Its first kind of energy level will have 2. So that means its second energy level, its valence electron shell, will have 6 electrons. So for it to complete its octet, it needs to borrow or share 2 electrons. So that's why it forms 2 bonds, to borrow 2 electrons with carbon, okay? Oxygen is very electronegative, so if we think back to kind of polar molecules, this thing is going to definitely have a negative charge on it. Okay, that's more for later. Again, R refers to, there's an unspecified kind of chain that's with it, okay, on the end, okay? Okay, these are found at the ends of molecules. Okay, to name organic acids, identify again the longest chain containing the carboxyl group and replace that final E with OIC, oic, and then followed by acid as a separate word. Number the carbons starting with the carboxyl group. Okay, so starting with the carboxyl, this becomes 1, 2, 3, 4, 5. So we start. This is a carbon that's included in the counting. So 1, 2, 3, 4, 5. So 5 is pent, and then we change the end of it to oic. So this becomes pentanoic, and then we put the word acid with it. So this is pentanoic acid. Okay? The next one, count the carbons starting from the hydroxyl group. So that's 2 carbons. That has the root name of N, and then drop the E, add OIC, ethanoic acid. Okay, this one has 5 carbons with it, so it's like this one, pentanoic acid, but we've got an attached methyl group on carbon number 3, so this becomes 3-methyl pentanoic acid. Okay, this is 1, 2, 3, 4. This is butanoic acid. Okay, and then on carbon number 2, we have this attached ethyl group. So it becomes 2-ethyl butanoic acid. Okay. The nice thing is that your carboxyl group is always at the end. Okay, it's always at the end. No, look what I noticed here. There's a little mistake with this one, right? This one needs to have a bonded oxygen with it there. Okay. The next group, an ester. Okay, actually we're going to do a very interesting lab about esters, and esters are one of the main kind of reactions that you'll need to know for your exam, how to make an ester. So what an ester is when you have an alcohol and it gets combined with a carboxylic acid. So when you have an acid plus an alcohol, you can make these things called esters. And esters are really cool. That's why we're going to do a lab with them. Everything that's got a smell to it, a nice smell, like you smell apples or the smell of bananas or strawberries, that smell that you're getting from it, that specific nice smell, that's an ester. That's made up with this, right? So we can combine some acids with some alcohols in our lab and make up some of these same wonderful scents that you have in nature. And that's how a lot of perfumes are made too. They're all esters. So esters are really cool things. So after we do some work, I want to maybe our last final lab of the year, make some esters because they're pretty cool, and you'll like it. You'll go, wow, that smells like cherries, or wow, that smells like strawberries. Yeah, it's pretty cool. Okay, so it says here, esters are a group of compounds that are formed when the hydrogen on the acid group, okay, so there's your carboxylic group, this hydrogen, is replaced with an alkyl group. Okay, esters are the products of reactions between carboxylic acids and alcohols. So the general formula is, okay, so we still have that double bonded oxygen, and we have this hydrogen too, but our H has gone away. Okay, and then what we can do then is, because these are at the end of a molecule, you can use them to combine two kind of chains together. Okay, two chains get combined together, and this oxygen here forms a bridge. Now these are ones that are a little bit tricky to name. Okay, so please try your best and please pay attention because I might make a mistake here myself because they're tricky. So the alcohol group that's bonded is called the alkyl group, and then you can notice the original group, which is the acid group. Okay, so an ester name has two word names, and the first word is the name of the alkyl group. So that's weird. So the back part of it goes first, the alkyl group. Okay, and then the second word is the name of the acid group from the ester, which was called ic, but now you change the ic, the acid group, to 8 on the end. Okay. So let's look at this example. Okay. So this part here was the acid part, and this part here was the alcohol part. Okay. So this part was formed from the alcohol, and this part was formed from the carboxylic acid. Okay? So, the carboxylic acid group has 2 carbons in it, so we know it came from ethanoic acid. Okay? This is a good question from the test. Here's an ester. What were the 2 things that it came from? That would be a good question to ask too. Okay. The alcohol group, this had to be methanol, right? There's 1 carbon on it, so it was 1 carbon and it had an OH on it, so it had to come from methanol, but the name is methyl. So you put this group, the alcohol group that it came from, goes first, and so the whole name becomes methyl ethanoate. Methyl ethanoate, and that's your name of your ester. A combination of a carboxylic acid with an alcohol. Okay, these ones require a bit of practice because you've got some backwards thinking. So, how should you approach these questions? So the first thing you should approach is what was your alcohol group and what was your carboxylic acid group? So your alcohol group, because it comes first. Okay, this was your alcohol group on the other side of the oxygen. Okay, this was from your alcohol. Okay, this part was from your acid. This was from the carboxylic acid. It contains the double bond and the oxygen. Okay, so the alcohol part goes first in the name. So this becomes ethyl, because we've got 2 carbons. Comes ethyl. And then this has 4 carbons, because we include this carbon in there too. So 4 is butane. And this came from butanoic acid, but then we changed the oic part to 8. So this becomes butanoate. So the name of this is ethyl butanoate. So if I gave you something like this on a test, a great question would be, again, what carboxylic acid and what alcohol formed this? So that alcohol had to be ethanol that made it, for the ethyl part. So it had to come from ethanol, and this had to come from butanoic acid. Ethanol plus butanoic acid made this. Okay. Let's look at B. Okay. So the first step for doing these, well, the first step is to realize what you're dealing with. The first step is to realize you're dealing with an ester. Okay. Look at it. Oh, I'm dealing with an ester. Okay. Because I've got this would have an OH and it would be at the end of the molecule if it was a carboxylic acid. It would just simply have an OH in it if it was an alcohol, but this is an ester. So, the second step is, after I realize it's an ester, then I need to identify the alcohol group and the carboxylic acid so I can see where it came from. So this part here came from the alcohol that formed it, and this part here came from the carboxylic acid. A noise outside. Okay, the alcohol group comes first in the name. So this is 1, 2, 3, 4. So that'll be butyl. And then this one is 1, 2, 3. 3 is propan. And then to show that it's an ester, it has to be O8 at the end. The name of this is butyl propanoate. Okay, again, first step, realize what this is. This means that this is an ester. Okay, so you have to be able to recognize that. The second step is identify your alcohol group and your carboxylic acid group. So this was your alcohol. Okay, this part was your carboxylic acid. Okay, the alcohol group goes first. I know it's hard because the part that we should be going from left to right, but now we're going right to left, and it's all backwards, but step by step. So your alcohol group goes first in the name. So 1, 2, 3, 4, 5. So that'll be pentyl. And then your carboxylic acid group has 1, 2, 3, 4, 5. It has 5, 2. So this becomes pentene. And then to show that it's an ester, it has to have O8 on the end. So this is pentyl pentanoate. Okay, again, first thing, recognize that this is an ester. Okay, then find your alcohol. Okay, find your carboxylic acid. It's a big carboxylic acid. Okay, so your alcohol group goes first. Oh, there's only one, so that's easy. So that becomes methyl. And then let's count the carbons. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Ooh, 10, dec. Decan O8. Methyl decanoate. That's what that is. Okay. So those are your esters. I'm wondering how long we're at 40 minutes. I'm wondering how much more I should do here. If this is a natural place to take a break. Maybe just keep motoring through these as much as I can. Okay, your next group you need to worry about is called the aldehydes. An aldehyde. So an aldehyde has a carbonyl functional group. So that's a carbon double bonded to an oxygen. Okay. In aldehydes, the carbonyl group is always, and this makes it easy, it's always found at the end of the carbon chain, and so this means that it helps you with numbering it. That means that that carbon becomes carbon number 1, okay, because it's always at the end of the chain. We are going to name, the ending is going to have Al on the end to indicate that it's an aldehyde. It's an aldehyde, it's going to have an Al on the end. So let's try and name the following ones. So we've got 2 carbons. So the first thing we have to do is recognize that it is an aldehyde. So I notice I've got this double bonded oxygen and it's on the last carbon. Okay, it's either on the first carbon or the last carbon, but it doesn't matter. That will always be carbon number 1. So this double bonded oxygen, I'm dealing with an aldehyde. Okay? So 1, 2 carbons, so that's ethane, and then I'm going to use the prefix Al, or the suffix, part that goes on the end, Al, to indicate it's an aldehyde. Ethanal. Ethanal. Okay. Remember, you should also be able to work from the name to draw the picture. So that'll be something big that we'll start doing next, because you should be able to write the name of these things. You should be able to draw the picture of them too. So we should be able to work both ways with these. Okay, B. The first step is always to recognize what you're dealing with. So I've got a double bonded oxygen on the end of the molecule. That's going to be an aldehyde. An aldehyde. So how many carbons? 1, 2, 3, 4. 4, so that's butane. Al for aldehyde. Okay, next one. Ooh, there's a little trick to this. Okay, so first thing is I realize I've got a double bonded carbon, or not double bonded carbon, the oxygen double bonded, so it's an aldehyde. Okay, how many carbons is along this chain? 1, 2, 3, 4. So this is, again, this is butanal, but so this will always be carbon number 1 with your aldehyde group. On the second carbon, there is a methyl group. In my practice, I did this wrong. So either I'm doing it right now or I'm forgetting something that I thought of the other day. So, but anyways, I think this is a methyl group. I think I did it wrong before. So this becomes 2-methyl-butanal. Okay? Next one. Okay? Oh, I see that it's an aldehyde because of the double bonded oxygen at the end. And then how many do I have? I've got 1, 2, 3, 4, 5, 6, 7. Okay, 7, hept. So it becomes heptanal, or aldehyde, al. And then on carbon, so this becomes carbon number 1, 2, so I got 3, 4, 5, 6. I got 3, 5, and 6. So 3, 5, 6 trimethyl heptanal. 3, 5, 6. I've got an attached methyl group, so it's tri for 3. Heptanal, because it's an aldehyde. Okay? These other parts should be easy. It's just recognizing these new functional groups. So we looked at the alcohols, looked at the carboxylic acid so far. You should, if you can't remember, you should take a minute and pause and make sure you know what each of them looks like. Okay? We looked at the esters, the aldehydes. Next group is the ketone. And the ketone looks a lot like an aldehyde with an exception. So ketones also contain the carbonyl group, except in ketones the carbonyl group is attached to 2 other carbon atoms, and it is not found at the end of the chain. Okay, so look at here. So here's our carbonyl group, but it's attached to a carbon here, and it's attached to a carbon here. It can't be attached to 3 because we need to have 4 bonds. 1, 2, 3, 4. Okay? So when naming a ketone, the ending -one, that's not 1, it's pronounced -one, is used instead of al. Give the carbonyl group, what do you expect? Yes, the lowest possible number, and indicate its position in the name. So this one has 1, 2, 3, 4, 5, 6 carbons. Its root name is going to be hexane. We notice that we've got a double bonded oxygen, and it's not on the end of the molecule, so it has to be a ketone, and it's bonded to carbon number 3, so hexane 3-one. Okay, so first step is always recognize what you're dealing with, and you could say, oh, I remember double bonded oxygens, that's an aldehyde. Then you'd stop and you'd say, no, stop, wait, that double bonded oxygen's not on the end, it's on another carbon. Okay, so this is a ketone. This is 1, 2, 3, 4, 5. So 5 pentane. It's on carbon number 2-one. Pentane 2-one. Or you could write it, since there's nothing else there, 2-pentanone, like this. Not pentanone, pentanone. Is that what it's like that? Or not pentanone either, okay? This one, so I see it's a ketone. So 1, and they were kind enough to number everything for us, so I know it's heptane. And then it's on the 3rd carbon, so 3-one. But I also notice on carbon number 2, I've got an attached methyl group, so this becomes 2-methyl heptane 3-one. Okay. So this one, 1, 2, 3, 4, 5. If you said 5, there's 5 carbons there, you would be incorrect. You need to use the longest possible chain. So this the longest chain is 1, 2, 3, 4, 5, 6. So it's hexane. I'm going to try to find spaced right. So this is hexane, and then our ketone group needs to have the smallest possible carbon. So it could either be 1, 2, 3, 4 or 1, 2, 3. So 3 is smaller than 4, so it becomes 3 ohm. So that means that 1, 2, 3, 4, 5, 6. So that means then I've got 2 attached methyls. That means I've got 1 attached to carbon number 2 and 1 attached to carbon number 4. So that becomes 2,4-dimethyl hexane 3-one. Okay? Last one's pretty simple. Okay, we got 4 carbons, butane, and then it's on the second carbon, 2 ohm. Okay, or there's nothing else attached, so you could write it as 2-butanone. Would be fine like that. Okay, to make things, this is why we need lots of practice, to make things more tricky is before we had the esters, now we have an ether. Not an ester, an ether. Okay? Ethers, you recognize them because they've got this kind of oxygen that serves as a bridge. So they contain an oxygen atom bonded to 2 carbon atoms within the carbon chain. The general structure of an ether is this. We've got an oxygen bonded to 2 carbon atoms. To name ethers, identify the 2 alkyl groups on either side of the oxygen. Write the name of the shorter alkyl group, the alkyl oxy group, first, and then add the suffix oxy with it. Then oxy for oxygen, in case you're wondering why oxy, for the oxygen. Then write the name of the longer parent chain. Indicate where on the parent chain the oxygen is attached with a number preceding the name of the alkyl oxy group. This is a bit confusing. Okay, so the job was to indicate I'm wondering if I should take a break here because these start getting a little bit challenging. So for this one here, so the shorter group is a methyl group, okay? The longer group is an ethyl group, okay? And then we know it's an ether because it's got this bonded oxygen, okay? The only thing is, oh, I see how this works. Okay, I remember. Okay, so it is bonded to the first oxygen, so it's 1-methyl-oxyethane. So let's try this one. So first, what's the shortest group? The shortest group is 2. So this becomes ethoxy to show that it's an ether. The smallest group, ethoxy. And then we've got 3, so that's propane, ethoxypropane, and the oxygen is attached to how many other oxygens is attached to 1 other, so 1-ethoxypropane. Okay, so this one, indicate the shorter groups 1, 2, 3, 4, or 1, 2, 3, 4, 5. So the shorter group is bute, so this becomes butoxy, and 5-pentane. And it's attached to, we would, 1-butoxypentane. This one, the shorter group is propoxy, and then propane. It's going to be attached to the first carbon there. This one, though, the shorter group here is 1, so this becomes methoxy, and the longer group has 3, propane. So that's fine, but how is it, oops, I can't remember. So how is this one different? So methoxypropane, meth, there's 1, the shortest group is 1, longest group, there's 3, okay? But if we look at it, which carbon is the oxygen attached to on the longest chain? So this one, it's attached to carbon number 2. So this becomes 2-methoxypropane for that one. Okay? A bit of review, and then I think I'll stop for that. That's enough for today. A bit of review at the bottom. So let's see, 1, 2, 3, 4, 5, 6. So this one, simple alkane, you should be able to do this one in your sleep, hopefully at this point. So 6, hex, hexane. 1, 2, 3. 3, methyl, hexane. This one, I've got a ring. 1, 2, 3, 4, 5, 6. It's a ring, so it's cyclo. And then there's 6 carbons, hex. There's a double bond, so it should be ene. Cyclohexene, okay? That's nice. That means that that carbon gets number 1, 2, 3. 3-methyl cyclohexene, that one. Okay, OH. OH is an alcohol. This is also, what kind of alcohol? It's a secondary alcohol. This carbon's attached to 2 other carbons, so it's a secondary alcohol. So our parent chain is 1, 2, 3, 4, 5, 6. So hex. And its lowest number is 3, so it's attached to the third hexane, 3 all, or you could write it as 3 hexanol would be fine too. Okay, this one, we've got a carboxylic acid group. It's attached to the end of the chain, so this is an acid group. We've got 1, 2, 3. We've got 3 carbons, so this becomes propanoic acid. This one, propanoic acid. This one, we've got a double bonded carbon, and we find it at the end of the chain. That means that this is an aldehyde. So we always start with, that's going to be number 1 in the longest chain. So that's 1, 2, 3, 4, 5, 6, 7. So that's going to be heptane, and for an aldehyde, Al, heptanal. And then on the second carbon, I've got 1, 2, 3, a propyl group. This is 2-propylheptanol. Okay, and we are about at an hour. So we've got the amines, the amides left for next time, and then a bit of practice. Next time a little bit shorter. I think at about an hour, even myself, that's about all I can handle right now. So again, the key point is just practice, 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 and hopefully it starts making more sense with more and more practice. I know there are a few that I need some practice with too. I'm not exactly too keen on my ethers. I need some practice with ethers, and I know I need practice with the amines and amides as well. Okay? So cheers, good luck.